In this video, I'm going to go over how we can use dimensions as variables in equations when dimensioning our 2D sketches in Autodesk Inventor. So here I have open just a sketch with a couple of geometric shapes, and I'm going to start with the rectangle on the left. Now I'm going to start just by quickly placing my two size dimensions on here. So I have a 2.5 by 1.5 rectangle. Now this rectangle is not fully constrained. If I grab the sides and drag it, we see that it still moves and the lines are still purple, which means they're not fully constrained. In order to fully constrain this, I need to place a couple of location dimensions on here. So not just size, but also location. To do that, I would dimension from the edge of my rectangle to my origin point. And what I'm trying to do here is I want to center this rectangle over the origin point. So it's exactly half of the rectangle on the left and half on the right. So I'm going to place this guy up. I'm dragging it out of my sketch so it's not in the way. And I can do some mental math here. So I can say, okay, if I want this to be half on the left and half on the right, I would take 2.5 and divide by 2, which is 1.25. So there we go, and we can see that this has shifted over and the vertical lines on the two sides are black, meaning they're fully constrained. And if I try to grab and drag them, it doesn't go anywhere. It still just moves up and down. So I've managed to center this from left to right. But what about if my rectangle changes? So instead of a 2.5 rectangle, maybe I'm working with a 3.5 rectangle. Notice that it's no longer centered because I put this in as a static value, which means a non-changing value. I still have 1.25 of my rectangle on the left, but the right-hand side we can see is very clearly not equal, so it's no longer centered. So instead of putting in a static value, or instead of doing mental math in our head and typing that dimension in, what we want to do instead is when we do our location dimensions, we're going to do them as equations. Now, how did I figure this out? Well, what I did is I took the length of my rectangle, which was 2.5 before, but it's 3.5 now, so I took the length of my rectangle and I divided by 2. Well, instead of doing that in my head, let's get the computer to do it for us. Why not? We're working on this big fancy machine. It can do the hard work. So I'm going to say, okay, I want this dimension, which I'm going to left click on. So left clicking on the length of my rectangle and typing in divide by 2. So I'm getting the computer to do the hard work for me. Click the green check mark and we can see that it updates. This dimension now says f of x in front of it. F of x is the computer telling us that this is an equation, so it's a function of, and then it tells me what the value is, which is 1.75, which is exactly half of 3.5. Now here's the beauty of it. Let's say I change this back to 2.5. Maybe I can't decide how big my rectangle is going to be. This sketch that I'm making, or this part that I'm making, is constantly being updated and modified. So I'm going to come back in and change that, and you'll notice that it changes this dimension as well because it's an equation. So remember that this one constantly changes whenever this one does, because this one is equal to this one divided by 2. You'll also notice that the lines on both sides of my rectangle have gone black, meaning they're fully constrained. This guy does not move left to right anymore. He only moves up and down. So let's place our equation to stop him from moving up and down now. So I'm going to dimension, and again, I'm trying to keep him centered over the origin point. So I'm going to dimension from the top line of my rectangle to that origin point, drag that to the outside and place it. And this time, again, I could take 1.5 and divide by 2 mentally, but let's type this in as an equation. So instead, I'm going to left click on the height of my rectangle, which is this 1.5, and then type in divide by 2. If I click the green check mark, we can see that this one changes to have f of x in front of it, meaning it's a function of, and its value is 0.75, which is exactly half of 1.5. You'll also notice our rectangle has gone fully black, meaning it's fully constrained. So let's double check that. If I change my 1.5 now to, oh, I don't know, let's go 3. Yep, we can see it updates for us, the magic of working on a computer here. So we can see that this updates to 1.5 and it is staying perfectly centered. So that is the wonderful thing about working with equations when you guys are typing your dimensions into your 2D sketches here. It saves you a ton of time when you have to come back and make modifications to the change of your, to the size of your part. Let's look at this guy over here now. So this guy's a little bit more complicated than a rectangle. I'm going to start by just dimensioning a couple of size dimensions on here. So actually I'm going to go 3. So I'm going to dimension the bottom, and I'm going to dimension my overall height here. Ooh, let's just do something like that. Okay, now I want this to be a perfectly symmetrical shape, which means the angled lines on both sides should be mirrored images of one another. This guy should be centered, and these guys on the left and the right should be the same length. So I'm going to start by dimensioning this line on the right. Let's place that. Let's make that 1.75. Okay. So I've changed the height here. Now I want this line here on the left to be the exact same height as this one on the right. So I'm going to have to dimension this one here and place it. Now I'm not going to just type this in again, because again, if I did that and this height changed later to, let's say, 0.75, well, this one doesn't update. So instead, what we're going to do is with this new one over here, I'm just double clicking to edit this one right here on the left. I'm going to backspace, get rid of everything that's in there, and I'm going to use an equation. This time I'm not dividing by 2 though, because Inventor can do any type of equation. So instead I'm going to say, okay, I want this one to be equal to this one. So I'm just going to left click on this 1.75 on the right. You'll notice that D6 pops up in here for me because that's the 6th dimension I've placed. And if I click the green check mark, this one is updated with an f of x telling me it's an equation or it's a function of, and then it gives me the value 1.75. Now when I come over here and I change this one back to 0.75, notice that the one on the left updates to match it. So that is the beauty of using equations again when they're equal to one another, even when you're not dividing by 2. So let's dimension again. Let's dimension the size of this one. This one I'm going to type in at 0.75. And now I want to equal my angular lines on both sides. That was a bad way to say that. I want these to be mirrored images of one another over the middle. I want to center this guy. So to do that, I'm going to dimension, and I'm going to dimension the horizontal component of this angled line right here. I'm just bouncing it on my screen so you can see. So in order to figure this one out, if I was to mental math it, what I would do is I would say, okay, it's my overall length of my shape down here, which is 3. So the overall length minus the length of this top line here, which is 0.75, and then divide by 2 because I have equal spaces on both sides. So it would be 3 minus 0.75 divided by 2. So let's type that in. We can do fancier equations using our order of operations in Inventor. So I'm going to place this one and backspace whatever's in there, and I'm going to say, okay, 3 minus 0.75 divided by 2. Now is this right? No, this is not right. And the reason for that is our order of operations. If I hit enter right now, it's going to do these in the wrong order. It's going to take my 0.75, divide that by 2, and then subtract that from 3. That's the wrong order. What we want instead is to use our brackets. So I'm going to do open bracket, and I'm going to say 3. So left click on the 3 minus, so subtract symbol, 0.75, and then close bracket because I want it to evaluate this equation first and then take that answer and divide it by 2. So hit the green check mark, and you'll notice it's updated and it says f of x, meaning it's a function of, and the answer is 1.125. Now, what if I want to make sure it's the same on the other side? So I'm going to dimension. I'm going to dimension the horizontal part of the other side, and we can see right away that, yep, it is 1.125. That's awesome. So we can see our equation worked. So that's how we can use even more complicated equations in Inventor when dimensioning our sketches there. So we've gone over just centering a rectangle using length divided by 2. We've gone over equaling 2 sides to one another, and we've gone over a fairly complex equation using our order of operations. Now, if I place this dimension on the right here, let's just talk really quickly about reference dimensions or driven dimensions. So if I place this guy on the right, we're going to get a pop-up here, and it's a little error saying that this will over-constrain the sketch. And the reason for that, if I click accept, So the reason for that is I already have the length of my object. I have this length, I have this length, so this one can only be one length. So you're going to get a pop-up when you're placing a dimension that cannot be edited. Now you'll notice I clicked accept on that little error that popped up, and it placed the dimension, but it put it in brackets. So when you have a dimension in brackets in Inventor, what that means is that dimension is called a driven dimension, meaning it's driven by all of the other dimensions in your sketch. This one cannot be modified. So if I double click on it to change it, you'll notice that it's grayed out on me. I can't change this value. It's just there for reference. So I call them, you're going to hear me call them both either driven dimensions or reference dimensions. It's the same thing. It's when you have a dimension that's in brackets that is evaluated based on all of your other dimensions on here, and it cannot be changed, but we can still use it to reference other parts of our sketch. So for example, if I placed a dimension, actually let's draw ourselves a little shape here. I'm going to just draw a line here quickly. And let's say I wanted this line to be the same length as this line. So I could dimension this line down here for the length. I'm going to backspace to get rid of everything that's in there, and I'm going to use an equation by saying I want this one to be equal to this one. So I'm going to just left click on my driven dimension up here and click the check mark. And you'll notice that this one is still updated. So the only time we really ever place dimensions in brackets so that we place those driven or reference dimensions is when we need to use them as part of another equation. So even though I can't change this value, I can use it in an equation such as down here for a dimension that I can change. So that's why reference dimensions are handy, is you can still use them as reference in other equations, you just can't change their value. So that was a fairly long video here, but we talked about placing dimensions and using our dimensions as variables in equations to make our sketches much easier. Doing this will make you a much more efficient designer, because when you come in to make modifications to your part, everything else will update automatically because you've placed them in as equations. It also saves you from having to sit there with your calculator or stress yourself doing a bunch of mental math, because Inventor, such as with this order of operations here, Inventor can do all of that hard math for you. And then again, just equaling two sides to one another, such as I did with this height over here and this one over here. That's a really, really handy thing, especially if you're placing, let's say, a bunch of circles that all had the exact same size. You could dimension one of those holes and then just equal each of these to the same size. So then when I update one, they both update in size. So this is a really handy tool in Inventor when dimensioning your sketches.